Hello all. Today we are going to discuss the last part, or we can say second part of exercise 2.5 polynomials. As we discussed in the previous video, this exercise is completely based on some algebraic identities. So it is a strong recommendation and suggestion for you that please just learn these identities first. Alright, so it will definitely help to solve these questions. Without identities we are not able to do these kind of questions. Alright, so let's start with the exercise. Alright, first question we have: verify x cube plus y cube equals to x plus y x square minus xy plus y square. Now first of all, I would suggest that please learn this question. Why I am saying to learn these questions? Because here it is a question, but afterwards it will be used as an identity. Yes, it is also an identity in which we'll say x cube plus y cube equals to x plus y x square minus xy plus y square. We'll use these two as a identity directly, but in this question we need to prove it first. So here we go. Let's consider the identity x plus y whole cube equals to x cube plus y cube plus 3xy x plus y. Alright, what we are going to do, just displacing this part to this side. Alright, so when we displace the symbol will be changed, so we can write x cube plus y cube equals to x plus y whole cube minus thrice of xy x plus y. Now here we can say we have x plus y both sides, so we can take x plus y as common. So here we have x plus y whole square minus thrice of xy. Now just expand it. X plus y whole square is x square plus y square plus 2xy. Now see, plus 2xy and minus 3xy will give us minus xy, and rest the same, x square plus y square. So we have an identity of x cube plus y cube, that is x plus y x square minus xy plus y square. Similarly in the second case we will consider x minus y whole cube identity, and x minus y whole cube equals to what? X cube minus y cube minus 3xy x minus y. So in this we will also displace this term to this side. So we'll have x cube minus y cube equals to x minus y whole cube plus thrice of xy x minus y. Here we can take x minus y as a common, so we have x minus y whole square plus 3xy. Now we need to expand it again. X plus y whole square equals to x square plus y square minus 2xy plus 3xy. So the minus 2xy and plus 3xy will give us positive xy, and x square plus y square is 3. So we have this identity. Just try to learn, if we have the positive symbol in the LHS, it means if we are talking about x cube plus y cube, then we have first sign is positive and then will be negative. If we have a negative sign in the identity, then we'll have negative sign first, then we'll have a positive sign. Alright, I hope you'll remember this. Now we have a next question. We need to factorize each of the following: 27y cube plus 125z cube. Now I would like to pay attention on this thing. Here we are using this as identity. Alright, so we have an identity of x cube plus y cube now, so it will be x plus y x squared minus xy plus y square. Why we are discussing this? Because 27y cube plus 125z cube can be represented in the form of 3y whole cube plus 5z whole cube. Now here x is 3y and y is 5z. Just put this value in the identity. X plus y, 3y plus 5z, x square, 3y square minus xy, 3y into 5z plus y square. So after solving it, we'll have 3y plus 5z. 3y square is 9y square minus 3 into 5, 15yz plus 25z square. Now I hope you are clear why I was asking to remember that, because it is an identity. Alright. Now see the second one, 64n cube minus 343n cube. So 343 is a cube of 7. So we can arrange it in the form of 4m cube minus 7n cube. Right. Now we have to use what? X cube minus y cube identity, that is x minus y, x square plus xy plus y square. Just put the values of x and y. Here we'll consider the x equals to 4m and y equals to 7n. So after arranging it in the identity, we'll have the final answer, that is 4m minus 7n, 16m square plus 28mn plus 49n square. Alright. Now moving towards, now we are going to use one more identity, that is x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Now we have a question, 27x cube plus y cube plus z cube minus 9xyz. Now we are going to arrange this question according to this identity, that is in the form of x cube plus y cube plus z cube minus 3xyz. So 27x cube can be written as 3x whole cube. Now y cube will be the whole cube of y and z cube is same. So we have 3x in the place of x. Just put this value in the identity, x plus y plus z. So in the place of x we have 3x. So 3x plus y plus z equals to 3x whole square plus y square plus z square minus 3x into y minus yz and z into minus 3x. Alright, just solve it. 3x square is 9x square plus y square plus z square minus 3xy minus yz minus 3xz. And the 3x plus y plus z is. So here we have a solution. Now you just need to take care of the identity. Alright, you must have to learn these identity. Alright. In the next one, we need to verify that x cube plus y cube plus z cube minus 3xyz equals to what? Equals to half of x plus y plus z and x plus y plus whole square plus y minus z whole square plus z minus x whole square. This is also an important one. Sorry. Alright, because we are using the same identity, x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z, x square plus y square plus z square minus xy minus yz and minus zi. This is the identity. Now what we are going to do, we are just doing it multiplying and dividing by 2. Alright. Now this 2 will be multiplied. Now this 2 will be multiplied with this whole term, this term. Alright, and this 2 will be in the denominator of the whole term. Alright, now what will be happen when we are multiplying the 2 with this term? Let's see. Half of x plus y plus z, 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx. Okay, now the question is why we are doing this, because we have to prove that it is equals to something like that, x minus y whole square and y minus z whole square, something like that. We need to prove in this question, right? So what we are going to do, we are just separating this 2x square in the form of x square plus x square. So 2x square is x square plus x square. Alright, 2y square is y square plus y square, and this z square is 2z square is z square plus z square. Alright, what we are just writing it we are just expanding the 2z square in the form of z square plus z square. Now just make a combination of these let's say we need to prove that x minus y whole square. So we are making a combination of x square plus y square minus 2xy, y minus z minus 2yz with the y square plus z square, z minus x minus 2xz with the z square minus plus x square. Now x square plus y square minus 2xy is the identity of x minus y whole square. Again will make y minus z whole square. This will make z minus x square, z minus x whole square. So we have proved it correctly. Alright, so just you need to take care of this, multiply and divide by 2. Alright, now next one is quite simple. If x plus y plus z equals to 0, we need to show that x cube plus y cube plus z cube equals to 3xyz. Now again I'll say, remember this one also, alright, because we are going to use this one as an identity also, right? Now x cube plus y cube plus z cube minus 3xyz what? X plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Now if it is given x plus y plus z equals to 0, now this whole thing is become 0. 0 into anything, it will be 0. So we can write x cube plus y cube plus z cube minus 3xyz equals to 0. Now just simply displace it, write it, x cube plus y cube plus z cube equals to 3xyz, hence proved. Alright, I hope you are getting this, because it's quite simple, because we just have an identity x plus y plus z, x square plus y square plus z square minus xy minus yz and minus zx. Alright, we are just putting 0 in the place of x plus y plus z. Now 0 into something is 0 obviously, so this will be this term will equal to 0 only, and we need to just displace the value of 3xyz and we get the answer. Now the next question is based on the previous identity. We have to following without actually calculating. This is the concept, this is the condition. We need to find the value of this without actually calculating. So we have minus 12 cube plus 7 cube plus 5 cube. Now what we can see, let's say x equals to minus 12, y equals to 7 and z equals to 5. Now if we add all these three numbers, minus 12 plus 7 plus 5, it is giving us 0. Now if x plus y plus z equals to 0, then x cube plus y cube plus z cube equals to 3xyz. This was the previous question. Alright, we have proved in the previous question. Now just apply this identity directly, so we can write it a cube plus v cube plus c cube, or x cube plus y cube plus z cube equals to 3xyz. In the place of x, we will put minus 12, y equals to 7, z equals to 5. Just find the product of this number and get the answer. Similarly, in the next one, 28 minus 15 minus 13, it will become 0 when we add all the three numbers. So if x plus y plus z equals to 0, then the x cube plus y cube plus z cube equals to 3xyz. So we just need to multiply 3 into 28 into minus 15 into minus 13. So we'll get the answer is 16,380, and it will be positive because we have two negative signs here. Alright, next question. We are given two quadratic equations, but these quadratic equations is representing area of some kind of shape, that is which is given as a rectangular shape. Alright, and we need to express in the form of L and B. So as we know that the area of rectangle is always L into B, and the quadratic equation has two factors always. Alright, so we are going to just factorize this quadratic equation by simply middle term split. Alright, so 25a square minus 35a plus 12. Now we need to split minus 35 in such a way so we can get two numbers whose product must be equals to 25 and 12, and after adding or subtracting it, we should get minus 35a. So we will choose 25a square minus 20a minus 15a plus 12. Now just took 5 a as a common from this, so you get 5a minus 4, and take 3 minus 3 common from this and get 5a minus 4 and 5a minus 3 as the factor. Now we are representing area in the form of two factors, so we can take any one of as a length and then second one as a breadth. So the possible expansion for length and breadth are 5a minus 3 and 5a minus 4. So this can be a length and this can be a breadth, or vice versa, we can just exchange also. Alright, similarly in the next one, 35y square plus 13y minus 12. So we are just separating by 28 minus 15. Just take 7y common from the first pair and minus 3 from the second pair, so that we can get the two desired factors. Alright, it's quite simple. Now the last one, again we have given two polynomials. Guess what are the possible expressions for the dimensions of the cuboids whose volumes are given below. Now the first question, the volume of a cuboid is always L into B into H. Alright, so we need to represent this expression in the form of multiple of 3 terms. At that, we need to represent these expressions in the form of multiple of 3 terms. Now see, 3x square minus 12x, just take 3x as a common and x minus 4 in the bracket, so this can be a length, this can be a breadth, this can be a height. So the possible dimensions are 3, x and x minus 4. Alright, now the next one, we have 12ky square plus 8ky minus 20k. Just take 4k as common and we have a quadratic equation. Just split 2y in the form of 5y minus 3y. So after solving this quadratic equation, we have two factors and the third one is here 4k. So the dimension possible dimensions of the cuboid are 4k into minus 1 into 3y plus 5. So we have completed the last exercise of this chapter. So please practice these sums, learn the identities. Alright, I'll send few questions for you. Alright, thank you.